Next, we're going to take a look at the grant boundary method. The grant boundary method is used to set loss corners on most of the non-rectangular entities within the public land survey system. It involves the comparison of distances between the record and the measure to establish a ratio for adjustment. Then a rotation is established between the two surveys for bearings. Its purpose is to preserve the angular relationship at the loss corner and to adjust the size, which are the distances, at the same ratio through each loss corner. Let's see if I can't make that a little bit more clear with an illustration. Here's a non-rectangular entity, and it butts up against a normal section. So it's in section 7. The normal section is section 7. So this is the southwest section corner of section 7, and this is the southeast section corner of section 7. These two corners are shown in the record to be on the section line. So what we have is this corner is existent, this corner's existent, this corner's lost, this corner's lost, this corner's existent, this corner's lost, these two corners are existent. A quick couple of notes, and I may be getting ahead of my illustration, but I want to point it out. This corner is just going to be a single proportion along the section line. It's going to use this corner and this corner because we do not proportion beyond found evidence. And so this is going to be a single proportion to establish this corner. We're going to use the grant boundary to establish these two corners. And this is all record information here. And you should have these illustrations in front of you whenever going through this lecture, so it makes it a little bit easier for you. So this corner is 10,000, 10,000. This corner is 8,197.07, 8430.01. These two are lost. This is 8,055.27 and 7184.09. In the southwest section corner is 10,010.93 feet, 4,883.01 feet. And again, these are all ground distances, astronomic basis of bearings. So to start with, I'm going to reestablish this corner using single proportion. So 5 is to 77.50. X is to 5,117.002 feet. So X is 330.13 feet. And so from here, because I said 5 is to 77.5, which is the summation of these two. So from the southwest corner on this line, I go 330.13 feet, and that establishes this corner. And the next thing I want to do is to deal with the lost two corners down here. In theory, what you're going to do is you're going to run the record around. And when you run the record around, you're going to end up establishing different points. And so in this case, I'm coming counterclockwise because the record was actually ran counterclockwise, so I'm following the record. So I run here and I set a temporary point. I run here, I set a temporary point, and I come here and I set a temporary point. Well, remember, this corner was found. Then what I do is I inverse between the two corners. And this is the record inverse. This is the measured inverse. And those inverses are shown here. The record is north 8326.42 east, 1253.037, and north 8330.25 east, 1253.963 feet. Next thing I'm going to do is to rotate the record to the measured. Okay, so here's the record, here's the measured. I'm going to rotate, so I'm going to rotate clockwise between the two bearings. And when I do that, I get north 0 degrees, 3 minutes, 43 seconds. And again, this is clockwise because I'm going record to measured. Next thing I'm going to do is to scale the record to the measured. So here's my record, here's my measured. I'm going to scale it, and the record has to grow, basically. So it's 1,253.963, which is the measured distance, and 1,253.037, which is the record distance, which gives me a scale factor to be applied to the distances of 1.000739005. Then what I do is I take this bearing and this bearing, and I'm going to go ahead and take this one too, and I'll explain why in just a moment, and I rotate the bearing clockwise by the rotation angle of 0 degrees 3 minutes 43 seconds, and I scale the distances by this scale factor. Once I do that, I scale all three, and then I calculate the coordinates of this point to this point and back to this one using this rotation to make sure that I check. And so it's just a check on my work. And a couple of things to mention is the rotation is easier in my opinion if you use azimuths. So I convert everything to azimuths and just rotate the azimuths, then convert back to bearings. And pay attention to your scale factor. Make sure if your record to measured increases that they do on all, and vice versa. So if the measured here is greater than the record, then the record needs to increase. If the measured is shorter than the record, then all the records need to decrease in distance.